Well, hello Internet, and welcome to my Matplotlib tutorial. In this one tutorial, I'm going to give you a really strong overview of just about everything Matplotlib can do. And if you don't know what it is, what it does is it provides numerous ways to create static, animated, and interactive visuals. It is the most popular plotting library for Python. It works easily with Numpy and Pandas arrays. And Seaborn, which I'm going to cover in my next tutorial, further extends its capabilities. So I have a lot to do, so let's get into it. Okay, so to install it, I'm just trusting that you know what Jupyter Notebook is, and you know what Numpy is, and you know what Pandas is. If you don't know, in the description, you will find information. But as this tutorial continues and I get to those points, I will explain what's going on. Okay, so to install Matplotlib, you can use one of 2 or 3 or 4 different options. Here are 2 of the most popular commands that you can issue to install it. And of course, you're going to need Numpy and Pandas as well. And in the description, you're going to find a notebook with, basically, it's a gigantic cheat sheet on how to do everything that I cover in this tutorial. So go and get that if you'd like. It would probably help you learn. First thing we're going to do is import Matplotlib. So I'm going to go import matplotlib.pyplot as plot. And then to make all of your plots show up in your Jupyter Notebook, you're going to type in this command like this and inline. And also we're going to import Numpy and Pandas. So import Numpy as NP, import Pandas as PD. And then I'm also going to put a couple other commands in here. This is going to allow me to reload the notebook whenever changes are made. So I'm going to say reload, auto reload. And also I'm going to say auto reload too. So those are just commands that are going to allow me to auto reload the page and such. Okay, and to issue commands, I of course just go control and return, or you can go shift and return, and that's going to create a new code block for you to work with. So these are all the topics that we are going to be covering in this tutorial. So, you know, a ton of different things, as you can see here. And the very first thing that I want to do here is just show you how to create a simple plot. So, first thing we're going to have to do is we're going to have to create X and Y Numpy arrays. So I'm going to just call this x1 is equal to, and then numpy. And what this is going to do is generate 10 floats from 0 to 5. And then I'm going to go and generate my y values just by taking the x values and squaring them. Now, if I want to display this plot, I just type in plt and plot and x1 and y1. And there you can see there is our plot. And once again, I just hit control return to get that to show up. Now you're going to be able to very easily add titles. You can just say plot and title and days squared chart, whatever you wanted to do. And you can see now that shows up in there. And I'm going to show you how to save these. And I'm also going to talk about figure objects and other more advanced things as this continues. Just starting off here simple. And if you would like to come in and add X and Y labels, just say plot X label. And we could say something like days. And then we could say Y label. And this could be days squared. And you can see now all that information's there. I'm also going to show you how to turn this information. There's so much to cover. It's unbelievable. Okay, so another thing that's important to talk about, if you are not in Jupyter Notebook, to show these plots, you're going to have to type in plt and show like this. But, whoops, show like this. But since we're using Jupyter Notebook, we don't need to do that. Okay, so there's the basics of how we can go and create a simple plot. And now what I'm going to do is show you how to print multiple plots. All right, so you're going to be able to print multiple plots all at the same time. And what you can do here with Subplot is define the row and column to print the plot with a number assigned to that plot. So I'm going to say that I want this to be row 1 and 2, and I'm going to assign that a value of 1. And then I'm just going to come in here and plot using our already created X and Y values. And if I would want to use red, for example, with the line, I can just type in R, you can type in K for black, W for white, B for blue, G for green, and so forth. And of course, there's more complicated ways of working with color, which we will cover. And I can come in here and just keep on going. So I'm going to do another subplot here, change this to 2. And I'm going to this time make this blue, just so you can see. And you can see that both of those are plotted out there on the screen for us. And that is how easy it is to go and create multiple different plots using the same piece of data. But now I'm going to jump and start talking about figure objects because I want to get out of the basics of Matplotlib and get into more complicated topics. Okay, so a figure is an object that's going to contain all the plot elements, and it can contain many axes. And whenever you create one, I'm going to call this figure 1. And you just say plot and figure. And you can come in here and define the width and height in inches by saying fig size. And I'm going to say 5 by 4. And you can define DPI. I almost never do this. So this will probably be the last time you'll see me do that, but that's what that is. And then you can come in here and add axes to these figures. So I'm going to say figure 1, add axes. And what you're going to define here inside of this array is the left, bottom, and the width and the height. So I'm going to say left and bottom and width and height. And these are going to range, basically this is 90% right here, and this is 10% right there. They're going to range from values of 0 to 1. And this is just representing the percent of our canvas that we want to use with this axes that we're drawing here. Then what I can do is say axes 1, and this is how you add labels to axes. So I'm going to stick with the same thing that I did before. I'm going to say days, and then I'm going to go and put a Y label inside of here. And this is going to be days squared. Don't worry, we'll get into more complicated fun stuff here in a minute. I can also come in and set my title just by saying set title. And the title that I put is, let's say, days squared chart. Now I want to come in and plot on this axis, and I'm going to say plot. And then I'm going to do pretty much exactly the same thing. I'm going to come in and type in my X array, so X, and my Y array. And then I also want to have a label generated that is going to be inside of the legend. So I'm going to say that the label in this situation is going to be X divided by X squared. And then I'm also going to create another plot using the same axes. So let's just copy this right here, paste that inside of there. And for this, what I'm going to do is I'm going to switch the X and Y values. So this goes in completely the different direction. And now let's change this to X squared X. And now what I'm going to do is add a legend. So I'll say axes 1 legend. And if you put location 0 inside of there, what it tries to do is figure out where is the best location to put your legend. And I can run this. Whoops, I got an error. That's because I forgot to put an equal sign in there. And also I forgot to put an underscore there. And there you go. All right, so you can see the legend up here in the upper right-hand corner, all the other information, and you can see that we were able to plot 2 different plots on the screen at the same time using completely different arrays and formulas. Now, I chose to use a legend of 0, which is best. Like I said, it tries to figure out where to put it. If you choose 1, you're going to get the legend in the upper right, which is where it ended up going. If you put 2, that's going to be upper left. If you put 3, that's going to be lower left. 4 is going to be lower right. And you can also supply a tuple that's going to be a XY value based off of 0, 0 being in the lower left-hand corner. So there's a whole bunch of different options for locating the legend on your screen. Now what I want to do is something even crazier. I want to create another axis directly inside of this axis, and then also put a plot inside of this. So I'm going to call this axis 2 is equal to, still using the same figure of course, and I'm going to say add axes, and I'm going to put 0.45. I'm going to make this smaller, 0.45 and 0.4 and 0.3. And then I can go and set all the information in regards to the labeling and such. So I'm just going to copy this right here, paste that inside of there, and then just change this to 2 and change this to 2 and this to 2. And then I'm also going to plot it. So I'm going to come in, I might as well just steal this guy right here. And you could do 2 plots if you'd want, but I'm just going to do 1. So there's plot 2, and I'm going to use X and Y. Not that it necessarily matters all that much, but I'll throw that inside of there. And then you could also throw labels on top of that, but I'm not going to do that this time. I am just simply going to come in here, and I'm going to set this to be a red line that's drawn. So there we did that. You can see that we now have charts or plots inside of plots. And let's say I'd also want to put like a text message inside of here. What you can do is you can supply, based off of the very center of the chart being 0, 0, you can say where you want your text to show up inside of here. So what I'm going to do is I'm going to say axes 2 dot text, and I'm going to say 0 and 40, and let's just say the message is just message. It's just whatever text that you want it to be, and you can see that I throw a message inside of there as well. So a whole bunch of random things you can do with basic plotting. And now I want to talk more about subplots. Okay, so as you saw, you're going to be able to define multiple plots with subplots, and it's going to handle creating the axes objects. So I'm going to come in and create a figure 2, and axes 2 is going to be equal to plot and subplots. And you can define your figure size directly inside of here. I'm going to use 8 and 4, which is something that I use a lot. And I'm going to say that there is going to be 1 row and 3 columns worth of plots. So I'm going to say 1 row, and I'm going to say that there is going to be 3 columns. And then what I can do is if I want to put space between these plots, I can say plot and tight layout. And tight layout is going to be something a command you issue a lot of times with your plots. If things are overlapping, just put this in there, and it more than likely is going to fix some things. And then what I'm going to do is you can actually access your plots by their index. So I have all these different plots. I'm going to say that I want to draw a plot in the second item. It's 0 indexed. So I'm going to say that I want to set the title to be plot 2. And I'm also going to do the same for the X and Y labels. So I'm going to throw both of those inside of there. And I'm going to change this to X label. And let's have this just simply be X. And then I'm going to have this be Y label. And let's have this be X squared, like that. And then I can come in and plot inside of just that one individual plot. And it's a nice, neat, organized way to be able to access and write in multiple different plots, or multiple different axes, however you want to refer to it. And if I do that, you can see that I wrote just simply in that plot. And of course, I could do the same thing, or I could use a loop and generate these plots or whatever I would like. All right, so another example there. using subplots in this situation. Now I want to focus in on a lot of appearance options that are available to you. Now, a lot of times you're going to use default colors, and the default colors, just to give you a list: B for blue, G for green, R for red, C for cyan, M for magenta, Y for yellow, K for black, and W for white. You can also do grays just by defining your color as a percentage of black. We're also going to be able to use hex codes, which means you can create all kinds of colors. And on top of that, you're going to be able to use color names like Burleywood, and you can find a list of color names at wikipedia.org wiki web colors. All right, so that's just one of the appearance options available to you, and there will be so many more that I will cover as this tutorial continues. But I'm just going to give you a rough overview here of appearance options that are available with numerous different plots. All right, so let's create our figure and our axes to draw, and just go figure 3 and add axes. And I'm going to say I'm going to take up all the space here this time, like that. And now I'm going to do a plot, and I'm going to do a whole bunch of different commands inside of here. So I'm going to say plot and X and Y, which you've already seen before, but there are so many more. I'm going to show you can use a color name. So you're going to be able to say things like navy. Maybe I should put a space inside of here so it's a little clearer to see. You're also going to be able to define the alpha of whatever the line is that you're going to draw. You're going to be able to define the line width, which I'm going to make it equal to 2. And basically, the line width is going to be 1 by default. So if you put 2 in, it's going to double it. What else? We can also go and generate different line styles. So let's say that I would like the line style to be a dash and a dot like that. I can do that. And there's numerous other different line styles available, line style options available to you. I'm not going to show you all of them, but basically this web page right here, it is going to show you all the different line styles. You can play around with these different dots and such to see what you come up with. There's also a thing called a marker, and what it's going to do is it's going to put a mark on the line everywhere you have an X and Y point that you've defined. So let's say that I would like to have a O there. Well, there's that. And if you want more information on those marker options, just go to that website. And I'm going to have all this in the description with the Jupyter Notebook that I provide. And of course, it's 100% free. You're also going to be able to change the size of the markers. So I'm going to say marker size is equal to 7. And that just increases it or decreases it. You're going to be able to change the face color, which they call it the face color, but I like to think of it as the fill color. So there is the marker color, and I'm going to say that I want it to be yellow. And then you can also define the edge or the stroke, depending upon if you use which type of jargon you want. I'm going to have that also be yellow. And you also can define your marker stroke width or edge width, as they refer to it here. And I'm going to have that be 4 as well. Another thing you can do is you can set the lower and the upper bounds of your X and Y axis. Well, let's just run this first. Oops, got a bug. Oh, I was talking and forgot to put face inside of there. All right, so there you can see the beginnings of our plot that we're creating here, and you can see how they have the dashes and the dots and the marker colors and all that stuff. Now let's say that I would like to zoom in here, so that I would only show the plot from 0 up to 3 on the x-axis and 0 to 8 on the y-axis. How can I do that? Well, I can just say axes 3 and set x limit. And then inside of here, I'm going to pass an array that's going to be 0 to 3. And then I'm going to do the same thing for my y. So throw y inside of there, and I said I wanted that to be 0 to 8. Boom, and you can see it zoomed in on that plot. And also, let's say like the background's kind of boring. Maybe I'd like to have a grid in the backgrounds. Well, I'm just going to go axes like this, and then I'm going to get rid of all that. And I'm going to say that I want to work with the grid. So I'm going to say that true, I want to add a grid. And the color that I want to define for this is going to be like a gray, 60% black color. And also I'm going to say that I want to have dashes on my grid, and they are going to be 5 points. And then we're going to have a 1 point dashes separated by 2 spaces. And let's see what that looks like. Remember, put your equal sign inside of there, and you can see there I now have like a grid pattern inside of it. And if I would also like to come in and change the background color for our grid pattern, I can come in and just come in, get rid of this part, and you say set face color. And this time, just to do it, I'm going to throw a hex code in here. And there we are. And now you can see we have like a brownish color back there for our chart. All right, so good stuff. There's just some of the most common appearance tools you're going to be using. And up next, I'm going to show you how to save your visualizations or your plots to a file. All right, so to save to a file, it's extremely easy. And you're going to be able to use pings and PDFs, PostScripts, EPS files, SVG files, and PGF files. I think that's all of them. So we're going to say figure 3 and save figure. And I'm going to say, what is this? Our third plot. So we'll say third plot. And I want to save it as a ping file. And boom. And I can come in here and you can see it's right there. And there is our plot, and it's saved for us. So pretty neat stuff, and it looks nice too. All right, so now we're going to talk about working with Pandas data frames. So let's say in previous tutorials I've talked about an ice cream data table, and this is what the data actually looks like. What it is every single month's average temperature and the number of ice cream sales sold. And it was just a way of testing to see as temperatures rise over the course of the year, does more ice cream get sold? Okay, so that's what it's all about. So that's what we're going to be pulling data from. So I'm going to call this ice cream sales, and this is a data frame. It's a Pandas data frame. So I'm going to say PD and read CSV, and you just put in the name of the file. So it's called ice cream sales CSV. So I'm going to pull in that data, and let's say that I would like to sort this information by temperature. I can say ice cream sales data frame is equal to ice cream sales data frame and sort values, and I'm going to say that it's going to be by temperature, which is, I had 2 options, temperature and sales. ICS data frame, and you can see there is all the information, and then I can plot it, of course. So let's get rid of this. And what I'm going to do here is I'm going to convert from pandas into a NumPy array. So I'm going to call this NumPy array is equal to ICS data frame and values. And then I want to get my X and Y values and put them inside of an array completely separately. So I'm going to call this X2 because you have to have an X array and a Y array. So I'm going to say NP array. And if I want to get the first row of information, or first column of information, I put in 0. And if I want to get, so that's going to be temperature information. And then for my Y, I want to get the second, so that's going to be 1. All right, so I created my X and Y from that CSV file that we had there. And now I'm going to go and create our figure. And let's go figure, and how about fig size being equal to, I'm going to say 6 and 4 should be good. and axes 4 is equal to figure 4 dot add axes, and I'm going to take up all the space again that's available to me. So bottom left hand corner to the upper right hand corner for my figure. And then I'm going to come in and set my titles and X values and all that different stuff. So I'm just going to come up here and copy this so I don't have to type all that out again. So let's come in, paste that inside of there, and then I have to change this to 4, of course, and 4 and 4. And then I'm going to give this a title, and the title is going to be ice cream sales versus temperature. And then on our x-axis, that is going to be the temperature. And because, see, temperature, that's that first column of information. And then the other one is going to be ice cream sales. All right, so I got all that in there. And axes 4 dot plot. And I'm going to go x2 and y underscore 2 and run it. And you can see right there, as the temperature indeed does increase, ice cream sales also increase. All right, and let's do a couple other funky weird things. Like let's say I would like to put like an annotation up here with an arrow that points at one of these months and says something, you know, strange. So I'm going to say axes 4, annotate, and let's say I wanted to say good month. I can do that. And what I need to supply is the X and Y value to point at. And you say XY like that. Whoops, you don't need the parentheses though. XY is equal to, and I know from looking at my chart that 8,3 and 5,3,6 is a point. It has to be a point that is, you know, one of your X and Y points. I then need to define where I want my text to show up based off of X and Y values. And what you do is you provide X and Y based off of the bottom left-hand corner of the chart being 0, 0. So you can normally figure that out just by looking at these axes numbers across the top and here. So I'm going to want it to be like in this general vicinity up here. So what I'm going to do is I'm going to say that 60 and like 520 in this general vicinity right here looks like a good place where I want the text to be. And then the arrow is going to point from the text to this point right here that you defined. So let's keep adding some stuff. I'm going to say arrow props is equal to dictionary, and I can change the face color on the arrow. So this is like information on my arrow that I want to draw. I'm just going to keep it simple, and I'm going to say that I want it to be black. And you can also shrink the size of your arrow. I'm just going to say shrink, and let's say 0.05 because that's something I do a lot and it works. And run it. You can see that it points right there at that very specific point. All right. So a whole bunch of random sorts of things. Hey, let's do one more. Let's say you'd want to have a bar chart underneath this. The point goes up to all the points just to do something. This might not look that great, but let's just do it just because it came to mind. So we'll say X and 2 and Y underscore 2. And now you got a bar chart under there too. All right, so a whole bunch of random types of things you can do here. And up next, I want to talk about text markup. All right, so you're going to be able to use a subset of text markup by placing text between dollar signs. If you don't know what that is, basically it provides you a way to go and draw in special characters for math formulas and special math formulas in general. Okay, so what I'm going to do is I'm going to have a plot here like this. And I'm just going to go in here and draw a whole bunch of random sorts of symbols. So I'm going to say axis 5 and text, and I'm going to say 0 and 23. So that's going to be, I'm just using these axes here. So I'm going to be drawing this text like right here is where I want to aim at. So that's what the 0 and the 23 are for. So what you need to do is use raw text, and that's what that does. And then you need to have dollar signs like this. So dollar signs, and then there's the end of the raw text. And then inside of here, you can go, let's say you want alpha, the symbol alpha to show up. Boom, now alpha shows up right there. And I'm gonna show you just a whole bunch of them. So let's say the beta character, and let's also throw sigma inside of here. I'm trying to show you everything that I regularly use. That is the goal. So epsilon, and I'm also going to show you things that I don't regularly use also. Pi and theta and lambda. Okay, there's just a couple of them, so you can see all of those characters there. And what else would we like to do? Let's throw in another row of these. So there's all those other different letters that are available to you. Let's go, and I'm going to show you a whole bunch of other different symbols that are available to you. So let's go throw another line inside of there. And let's move this down to like 18. That should be good. Let's say that you would want to use subscripts. So let's just come in and let's change this to delta, like that. If you want to have a subscript, just do an underscore and an I. And if you would like to do multi-letter superscript or just single letters, I'm going to do multiples just so you can see what that is. You're going to do it like this, and then list inside of your curly brackets what letters you want to show up inside of there. You're also going to be able to do sum. So let's say you wanted to do something like sum, and then you're going to go underscore like this to have what comes next show up under it. And I'm going to say I is equal to 0. And then for your superscript, you're going to go with this caret like that. And you're going to say to infinity. So there's the infinity symbol. And then we could do an x, I, and let's say also you want to do a fraction after that, just to be a complete nut. And for fractions, you're going to list what you want on the top, like that, inside of curly brackets, and then whichever you want on the bottom. And run it. And you can see that I created all of those crazy symbols right there for you as well. All right, what else can we do? Let's do some more. Let's go like this. And let's just go and put this on 13. And let's get rid of all of this stuff. Let's go, and I'm going to do a more complicated fraction just to show you how fractions are set up. So like I said, you're going to have fraction, and then inside of your curly brackets, you're going to define what goes on the top. So you could say something like 8 like that. And then let's say you wanted to put another fraction on top of that. You can. So let's say it's x like that, and 5. And then you could go and close off, whoops, all of the curly brackets. So that's going to be the top of your curly bracket. And then you're going to have this divided by 8 or something. And there you can see that crazy fraction shows up there. It's not looking very good right now though, because mainly because I'm zooming my browser in really far. So that's the reason why it looks a little bit distorted. You're going to be able to do square root. So let's say you wanted the square root of 9. And you're going to be able to do all of the different trig functions. So let's say you wanted sine of pi. You could throw that in there. Let's say you would want to do cube root. You're going to type in square root like that, and 3 like that, and then whatever you want your value to be inside of there. And there's also all kinds of other different symbols like acute, and whoops, what did I do wrong? Oh, I see what I did. I didn't put what letter I want with a little accent on, so I'm just going to have it be an A. And I just realized I didn't show you how to do a division symbol. You can just go div like that. And now if we run it, you can see all of those other different symbols that we just created right there. All right, let's go and let's do another one. And let's see, for this one, what I want to do is show you a whole bunch of other different ways of doing fancy type of characters. So I have this be like 8, and then let's get rid of all of this stuff and put in some new stuff. So different accented characters that you're going to use a lot. I use bar a lot. Remember, you put a little character after it. I use hat a lot, I use tilde sometimes, and let's just go and throw a whole bunch of them in here. So you can have vectors, you can have an overline, overline like that, and let's go this with our curly brackets. You can go and put multiple different characters inside of there, inside of curly brackets if you would like. And let's go and also do like a limit. So let's say you would have limit, and then under that limit, you're going to say x, and you can do, here's the symbol for 2, and then let's just throw a formula after it. That's just going to be f and x, just to do something, is equal to 5. And run that, and then you can see all those crazy symbols we have here, and a limit, and how to draw a limit inside of there. And what else do we want? Anything else? Oh yeah, let's do a couple more here. Let's get rid of this, change this to 3. And I want to show you some conditional operators and how to get those to draw. Obviously, you can draw a lot of them without doing special codes. So I'm going to say greater than or equal to. There's one of them. Less than or equal to. And not equal to. And I think that is everything I want to cover. And there you go. So there is a rundown of a ton of special characters you can use if you want to do different math formulas or operations and display them inside of your graph. And now I'm going to start a whirlwind of different plots, and I'm going to talk about histograms. Okay, so what I'm going to do here is I went and created a couple NumPy random arrays inside of here. So they're going to go from 0 to 7, which in reality actually means it's going to go from 1 to 6. It goes up to 7, but not including 7. It's going to go and generate 5,000 of those. And what we're going to try to do here is simulate dice rolls and then figure out probabilities or frequencies of getting the different dice values based off of rolling 2 die. So that's what I'm doing here mathematically. So if I want to plot a histogram, I just go histogram like this, and I'm going to be using array 3, which is a combination. Now there are a total of 11 different combinations with 2 dies. So I'm going to define that fact inside of bins. You can refer to these as bins or buckets. They just represent the number of options available. So I can roll between a 2 through a 12 with 2 dies. So well, that equals 11 possibilities. I'm going to define density, and density is going to return the frequency of each of my bins. So I'm going to say true, and then I'm going to say stacked is going to be equal to true. And if I run this, you're going to see that it is going to, stacked is going to say to print out all this information you see up here on all these probabilities. And you can see right here, based off the 5,000 die rolls, the histogram that is going to represent the frequency or probability of getting all these different values. And if I change this, I should probably get it to eventually even out. See, it's getting more even. And of course, the more die rolls that I take, the more it's there. That's perfect. So it's 7,000. We get an absolute perfect, because there's way more 7 possibilities for rolling 7 than there is anything else with 2 dies. So that's exactly what we want to say, and that is a representation of what you can do with a histogram. And there's other different options available for you when you're going and creating a histogram. You're also going to be able to define a range by providing a tuple, which is going to define that, let's say that you're only interested in die rolls between 2 and 8. It's just going to show you that, and you define that with a tuple. If you have cumulative true, that is going to create a cumulative distribution. I mean, I can go and throw these things in here if you want to see what that looks like, or you can experiment on your own. So like that, say a cumulative distribution. And you can also just show a line plot just by putting hist type and step. So let's say I wanted to come in here and replace it like this. and it creates a line plot, as you can see right there. And orientation, you can also have this be horizontal. So let's go, why not just go and put that inside of there just so you see what that is. Sometimes things get messed up though. See, and that doesn't look very nice, but that is a horizontal histogram plot. And of course, like with numerous other different things, you can have this be orange or change the color. Whoops, I'm sorry, I thought I typed in orange, and orange, for example, and change the color of your plot. All right, so cool stuff. And also on top of that, you're going to be able to, like if you put another plot on top of this histogram you have here, you could also get that to show up, but I already showed you how to do plots on top of plots. Remember back here where we had a plot and a plot? So if you want to go in there and for homework, figure out how to have a plot of the die rolls over top of your histogram of the die rolls, I'm sure you can figure it out, so give that a try. And that's histograms, and now I want to talk about bar charts. Okay, so for our bar chart and the next example, what I want to do is I want to go through the percentages of how France gets its electricity. So 71% comes from nuclear, 10% from hydro, and so forth and so on. And also we're going to have the variance per year also on top of that. And I'm going to show you a neat little bar chart that represents all that. So what we're going to do is just say plot bar, and then I'm going to throw in X is going to represent all of the different options that we have. And then we're going to have this be what we're going to be plotting, which is going to be the percentage that comes from all these different options. I can also define that I want this to be purple, because why not? And what else do I want? Oh, I can also put variance inside of here. So variance, and there you can see. And you can also see the black bars here represent the variance for all the different electricity options from the country of France. And of course I could put titles, and I could put X and Y labels and all the things that I've covered before, but I'm not gonna go and cover that because you've already seen it. All right, so let's go and do another one. For this example, what I want to do is I want to go through the percentages for males and females in the different branches of engineering. So I went and created that. I can say that I want to get evenly spaced values for each of my intervals by saying SPC. Oh, and if you did bar H for this, for example, would be like this. It would be a horizontal bar chart, okay? But you can go and experiment with that. Okay, so again, I want to get evenly spaced values for my intervals. So I'm going to say MP and arrange, and I have 5 different pieces here. So I'm going to say this is going to be 5. So that's what that's going to be used for. And now I need to go and plot all of these different plots for the men and women engineers. So I'm going to say plot and bar, and I'm going to put in the space and male engineer information, and I'm going to define my width for the bar, and I'm going to have this be 0.45, and I'm going to put a label which is going to be male, and I can also define a edge color if I would like to have my bar charts be surrounded with black, for example. I could say edge color is equal to black, that's K. And then I'm going to also draw in for female, and I'm going to have this be space plus 0.45 so that they are nicely laid out next to each other. And I can have everything else here be exactly the same except this part. I'm going to have this be female like that, and I'll leave the edge color as black. I could also define tick marks that I want to show up underneath my bar chart by saying plot and X ticks, and they will show up in the middle of my charts. If I just set it up like this, divided by 2, that's how everything else is divided by. So divided by 2 means in the middle of all of it. And then I can just list out all of my different engineering types. So I could have like aerospace, chemical, and civil, and electrical, and mechanical. All right, good stuff. And run it. And you can see that it plotted out all of that information exactly as we would expect it to. All right, so cool stuff. We're making more and more and more advanced charts. And I'm going to go and comment that out so I don't need to look at that again. And what I'd like to do now is show you how to do a stacked bar chart. So we talked about a field that's kind of dominated by men. Now let's talk about a field that's dominated by women, which is teaching, something dear to my heart. So I'm going to say, let's have this be kindergarten and elementary school teachers. That's what this is. And secondary school, and let's do special education. And then I'm going to say the male teaching percentage is going to be NumPy array. And then I'll just throw in the percentages. So I'm going to say 2 and 20 and 44 and 14. And then I'm going to do similar for female teachers. So let's change this to F. And in this situation, this is going to be 98 and 80. And this will be 56. And this is going to be 86. And then after we do that, I'm going to create a index here. And I'll say X for X underscore in enumerate T type. And then what we can do is plot these bar charts. So index and male teachers, and again I'm going to do like the same width again is equal to 0.45. I'm going to throw a label on top or with this, which is going to be male, and I'm going to define that underneath the male bar chart, these are stacked bar charts, I want the female information. So I'm going to say underneath of it I'm going to have the female teacher information. And then what I can do is go and you can stack these, put 5, 6, 7 of them on here. Do whatever you'd like. And then I'm going to have my female teachers like this. And this is fine, this is fine. This is going to be changed to female. And the only thing is after you don't have any more stacked underneath, well, this part goes away. So that goes away like that. And then I'm also going to plot a legend, and just to show you, I'm going to say location instead of best is going to be in the lower right like that, and run it. And what I do, X for X, run it, and you can see we created a stacked bar chart. And so a lot of neat stuff there. And up next, I'm going to talk about pie charts. All right, so now on to pie charts. And I'm going to import the random module here because I'm going to be generating some random colors. And what we're going to do here is we're going to create a pie chart that is going to have all the Pokemon and the number of Pokemon of each Pokemon type. So, you know, something that you probably will need to do someday. So what I want to do here first is I want to generate a random color array for my pie chart. So I'm going to create an array here. And then I want to use white text on dark colors. So I'm going to say for I in range. And I have 18 Pokemon types. And I'm going to say RGB is equal to. And then I'm just going to generate random floating point values. And I'm going to go from 0 to 0.5, so that if I wanted to get light colors, I'd have 0.5 to 1, but obviously I don't, so that works. And then I need to generate 3 random colors, so just do this 3 times, and there we go. So we got our random colors, 18 random colors, and then I'm going to say colors append like that. I could have did it differently, but that works. So there we go. So I generated a different color for each of my pie slices. And let's say I would like to explode one of my slices. What you need to do is you can actually explode multiple slices, but you have to say by how much you want them to be exploded. First off, I need 18 of these guys, and I'm going to say that I want to explode out just whatever the first one is. And this number right here is going to determine how much it explodes out. So make sure you spell explode right. And you can play around with those to see how much the distance varies. And then I'm going to come in here and I'll say wedges text auto text is equal to, and text like this, that works. Okay, is equal to, and then I'll plot my pie chart. So I'm going to say pie, and I'm going to pass inside of it the Pokemon number. That's the number of Pokemon that have those individual types. So I'm going to say Poke number. And what else do I want? I'm going to pass in my explode array that's going to say which ones explode. And I don't know why I can't spell explode right. There we go. And I'm also going to pass in my labels, which is going to be my different Pokemon types. And also my color array. So colors is equal to colors. Also, I would like to have, since these are, if these are going to be floating point types, what I want to, because this is all going to have to be equal to 100. So that means these are going to be displayed as percentages of 100, depending upon how big the number is. So I can go auto percentage, and I can define how many decimal places I want each of those generated values to have. So I'm going to say that I want 0 floating point values. And go like this, and that is going to handle that. And if I want a shadow underneath of my pie charts, I just pass in true to that. You can also determine the starting angle of rotation. So this is something that you sort of play around with. I'm going to say that I want this to be rotated 140 degrees. And what else do we want? I'm going to say that I want my text to be a white color. So dictionary and color is going to be equal to white. And there's also a way that you could go in there and have them be different colors, but for me, that works out fine. Another thing is, let's say that I would want to put a legend with my pie chart. I can just say legend and then pass in the wedges, the types, and let's say that I want the location of this to be to the right. Well, I'm also going to want this to be off of the pie chart. And to do that, what you can do is you can move it off. And what I want to do here is I'm going to say bbox to anchor. And what this is going to say is that I want to move 1 1/2, because I'm going to the right, 1 1/2, so to the right side of the pie chart. And I think I did everything right. And I run it, and you can see, move that 1 1/2 over from that pie chart area. And you can see all the text is white. You can see we have dark colors here. You can see that we went and floated this out. You can see the shadow and all of the other stuff. So those are numerous different settings you can use whenever you are creating your custom pie charts. And up next, I'm going to show you how to plot time series. All right, so I got this from Yahoo Finance, and you can just go into finance.yahoo.com, quote, and this is Google. That's their ticker. And then you can say history. And then what you can do is you can come in and define dates in which you want to pull price information, and then download right here as a CSV file. You can get daily information, weekly, monthly, all kinds of different stuff. And I went and downloaded that CSV file, and now I'm going to import it and show you how to plot that changing data. And I'm also going to show you how to do this later on whenever I cover Matplotlib Finance. It's a really cool module that a lot of people don't know about, and I'm going to cover it as well. So I'm just going to read this in as a CSV file using Pandas, and I named it Google CSV. And if I say Google data like this, you can see the dates and the opening price, high, low, closing. You can see that we have 63 different dates worth of information. I'm going to want to go and convert this to a NumPy array. So I'm going to say Google data to NumPy. And sometimes things work better as NumPy arrays. Sometimes Panda arrays work. It all depends on your situation. I'm going to then get an array of prices by getting just what is in the fifth column. So CP is equal to Google data and NumPy. And to get the fifth column, you put colon and a comma. And I covered this in my NumPy tutorial. But if you go and look at this stuff, there you can see so this would be 0, 1, 2, 3, 4. So I'm getting the closing price. I don't want all of this. I just want this to be 2 decimal places and so forth. So I'm going to play around with that as well. Or actually, you know what? It doesn't even matter in this situation. So I'm actually going to show you whenever I cover tables how to get rid of this excess decimal places. So I'm going to leave that for the next thing, which is coming next, how to print tables. So what I want to do now is I want to get our NumPy array with just the weekdays, and I also want to exclude certain holidays. Well, I know based off of looking at the data, this is scrubbing data. You're going to spend a lot of time scrubbing data. I'll get more into scrubbing data in later tutorials, like whenever I cover Scrapey and a whole bunch of other different things. So I'm going to say that I want between May the 25th stock. No, this is going to be the dates I'm excluding. So I looked at my dates. This ended up being a holiday, and then I have one other holiday in the time frame in which I'm looking at, and that is going to be on 8/19. So that's what I'm doing. This is an array that is just holidays that I want to exclude when I'm scrubbing this data. Then I'm going to go date array is equal to pandas, and I'm going to call b date range, and I'm going to start from, and I can define the time period that I want to pull the data from. And there's a date in this, so that makes that very easy. And I'm going to say that the ending period is going to be 8/19 and 2020. So there's that. And we set our frequency to be equal to C. And then I'm also going to pass in the holidays, which is going to be periods in which we don't have any data. So holidays, and I think that handles everything. And then I am going to convert this into a NumPy array. So date array NumPy is equal to date array dot to NumPy. And then I need to actually create the whole thing. So I'm going to create a figure here and define the figure size. And I'm going to go with my maximum amount that I have here. And like I said, I can put DPI in there. I'm not going to. And axes is going to be equal to, again, figure 7, add axes. And let's just give a little bit of a padding on the sides of this. 1 and 0.1. And then we'll have 0.9 and 0.9. All right, so there we are. And after I have that defined, I can plot all of my information just by saying date array NumPy and pass in Google CP as well. Oh, and I forgot to import date time, so we need to do that. Import date time. And if I run it, you can see all of the pricing information for our Google stock price over our defined date time. All right, so cool stuff. And like I said before, I'm going to show you how to do a whole bunch of other really neat things with stocks coming up. But next, I want to talk about tables. All right, so what I want to do is I want to take this Google stock data that we have here, and I want to format it so that all of the prices only have 2 decimal places. I could do this inside of a function, but I'm just going to do this the quick and dirty, get it done way right now. So I'm going to get the opening prices and get the series like this. And then I'm going to call round on all of the values in the opening column, opening price column. Set that to 2 decimal places for val in Google data, specifically the column labeled as open, and then index is equal to Google data index. And I'm going to do this for all of the pricing columns. So there is 5 of them, I think. So we have open, we have high. So I just need to change these right here, and it will round all of those prices for me. Do the same thing for low. Do the same thing for our closing end of day price. And also we have the adjusted closing price and the adjusted closing price. All right, so after we do that, we can go Google data, and you can see that all of these have been rounded. So good stuff. And what I want to do now is I want to get the most recent last days of stock data, and I'm going to put those in a table. So I'm going to go stock data is equal to, and Google data, and -5 colon, and that's going to give me the last 5 days. And then I'm going to define my headers that I am going to use for my table. So I have date, and I have open, and I have high, and I'm just pulling it from here, right? The table you see underneath here. And I have low, whoops. And of course I could change these. These are just something I'm defining. Close and adjusted close. You just need one for each column, otherwise you'll get an error. And volume. All right, so those are the headers for my tables. And then I'm going to take my stock data, and I am going to convert it to a NumPy array. So stock data dot to NumPy. And then what I'm going to do is I'm going to add some padding around the cells in the table. So I'm going to say plot and figure, and line width is going to be equal to 2. And I'm going to use tight layout again. Remember I said anytime things aren't looking good, play around with tight layout. One thing I didn't cover is you can define how much padding you want, and then you can have even more control. So you can play around with the padding and see how that affects what we're working with here. And let's just do like 5 and 3. And then I'm going to go, and whenever you use the generator for the table, it automatically is going to create an axes and a plot box with all the information. Well, you can try that. Just don't do what I'm doing right now to see what that looks like. But I don't want that. I just want a table. So this is how you get rid of the plot that shows up above it. Axes 8, and you say get x axes, and you set the visibility to false. And then you're going to do the same thing for y. So just change this to y-axis. And then also you have to get rid of the plot box. So plot box, and whenever it's on, just say none, and there you go. So those 4 lines got rid of the plot that shows up above the table. Don't do that, and then you can look at the plot above the table if you'd like. Okay, so what else do you want to do? Well, I am going to come in here and I'm going to create a color map. There's all these like customized color maps. Oh no, I'm going to show you some more color maps later on whenever we do some 3-dimensional plotting and a couple other different things. But basically, if you go to this specific URL, what it's going to do is it's going to show you there's all kinds of built-in different gradients and built-in colors. And like I said, I'm going to show you more with color maps later. This time, I'm just going to define a color map. It is an array. And what it's going to do is it's just going to give me a flat blue color. So this is how you can use that with your tables. And I'm going to say that I want my cell text, and to create the color map, you use CM, and then you define your color map's name. So my color maps that I'm using is blues. There are a whole ton of them. So you can go to this URL and you can look at other ones. Like I said, and later on in this tutorial, though, I'm going to show you a bunch more in actual real life, situations. So I'm going to say for column head, I'm going to have the column heading area be slightly different than the rest, and that's going to look nice. Okay, and what I'm going to do is I'm actually going to create my table. So I'm going to call this the table is equal to plot and table and cell text is equal to, and that's going to be our NumPy data array, so stock data np, and I'm just going to say that I want to locate this in the center. So there's center, and I'm going to define the column labels. You can also define row labels if you would like them, and the column labels are the only things that I need. So I'm going to say column head. So just create another row or another array that has row labels if you want to use them, and you can just plug them right in here just like that. And it would just be row instead of COL. All right, so pretty simple. And then also I'm going to have colors for my row labels is equal to CC colors. Like that. And you can also have row colors. So just change the COL to row, and you can have row color changes and so forth. And what else could we do? I think that's good. I think that's the whole thing. And there's one other default. I'm not going to use it, but you could say row location and then define alignment. So you could say left or right, and that determines how the text in the cells on each row are aligned. So that's row location or row lock, if you didn't see me type that in. All right, and that's the only other thing that I can think of. And let's go and define also our font size. So I'm going to have this be set the font size, and let's make it 14, and let's also scale our table. So I'm going to say table scale, and I'm going to have this be like 3 by 2.5. I think that's everything. Oh, and this happens all the time. It's always best. I forgot to put figure size in there. That's all. I do that all the time. I don't know why. So let's get rid of this here and put an equal sign in there and run it. And there you can see we were able to create a pretty nice looking table from all of that data. All right, so there you go. That's how to create tables using Matplotlib. And now I'm going to talk about Scatterplots. All right, so when I was making this tutorial, I thought, you know what, nobody is sick of talking about the coronavirus. So I decided to do some charts about the coronavirus. So what I did was I went and got a whole bunch of countries and some data. I have death rate per 100,000 from the coronavirus. I have daily confirmed cases, which is going to represent the countries that have tested the most people. And I'm also going to define that the dot size on our scatter plot, the size of it, meaning the radius of it, is going to be based off of the number of confirmed cases. So this is just a way of analyzing whether the countries that test the most have the least or the lowest death rate. All right, so let's see if that's true. Well, what I want to do here first is I want to take the CC array confirmed cases, because these numbers are so huge. I want to shrink them down. And one way to do that is just simply to come in and shrink them down by 1,000, by dividing 1,000. All right, so that's one way to make the size of our dots a little bit smaller. I am then going to create a random color array for all of our dots. Each of the dots is going to have a custom color based off the country, but it's going to be random. So I'm just going to say this and rand, and I have 26 total countries. So there's a random color for every single country. I am going to define the title, and it's going to be death rate per 100,000 versus confirmed cases. So this is confirmed cases is going to represent the amount of testing done. And I think I can move this up here because I think you see that. And of course, all that's available in the description for free. Just go get the Jupyter Notebook. It's there for you. All right, what else do I want? I'm going to put an X label on this, and that's going to be death rate per 100,000. And I'm also going to have plot, and the Y label is going to represent confirmed cases, and then I'll do my scatter plot. So this is a somewhat elaborate scatter plot. What I'm going to do here first is I'm going to put in the death rate array. So death rate array, and then I'm going to put the confirmed cases, meaning the number of tests that were done. So that's called the test array. And then S is going to be tied into the size of your dots. So this is going to represent the size of the dots. And like I said, you might have to divide by more than 1,000 or less than 1,000. It all depends upon what your data is. So array small. I'm inside of C. I'm going to pass in my random color array, and that's color array like this. So just paste that inside of there. And then I'm also going to say that I want the alpha on my dots to be half. So the dots are going to be on top of each other, so I want it to be half so you can see the dots underneath the dots. And if we run this, you can see indeed, there you go. And you can see that the, let's look at confirmed cases. So the bigger that is going to represent that there is more testing being involved, as is the test array part of it, and death per 100,000. So we can look and see this data and try to guess if more testing means less death. And based off of what we're looking at, it doesn't really look like that is going to be true. All right, so there you go. And just a random example using our friend the coronavirus and a scatter plot. You can do all kinds of cool things with scatter plots. And whenever I start getting more into data science, I'm going to be doing some real world examples using scatter plots and showing you how useful they are. All right, so there you go. And now what I want to do is talk about 3D surfaces. All right, we're going to need a new module here. So I'm going to say from MPL toolkits import mplot 3D. And this is going to be needed to create 3D axes. So let's go and create one. So I'm going to say figure 9 is equal to plot and figure and figure size is equal to, and let's get our maximum size here, so 8.5. And you can throw DPI in there if you'd like, why not? And then I will create my axes, and it's going to be a 3D axis this time. So figure 9, add axes, and let's do what we've been doing. Put a slight bit of padding on this, and this is the 3D part. You say projection is equal to 3D, like that. And you can see it created our 3D axes. And I'm going to create a whole bunch of 3D plots so you can see a whole bunch of different ones. So let's say we wanted to create a 3D scatter plot. You could do this with our coronavirus data if you'd like. What I'm going to do here is I'm going to define my Z, and I'm going to just say 15 times, and this is just going to be random, all right? So I'm going to say random, and 100 of those. And then my X just to give us a nice spread here, I'm going to have this be the sine of Z3. And again, this is going to be random and rand n 100. I'm going to do the same for y. And this is just so we can see some stuff. All right, so there's y, and that'll be exactly the same. And then what we can do is say axes 9 and scatter 3D. And you just pass in x3, y3, z3, and c is going to be equal to z3. And what you're going to see here is the darker points that are being drawn are going to represent what's closer to you. And I'm going to use a C map, and I'm going to use my blues one because I think it looks nice. All right, and we run it. Oh, and this is supposed to be sine. Hey, why don't I have this be cosine? All right. And there you can see is our three-dimensional scatter plot. And like I said, the darker dots are supposed to be closer, and the lighter dots are supposed to be further away. All right, so that's a scatter plot. Let's go and create another one. Let's say we wanted to create a contour plot. So go and do it. So to create a contour plot, you need to have a function for z that is going to be based off of x and y. So I'm going to create a function that is going to do that. So it's going to be passed x and y, and it's going to return, and I'm just going to use the sine function again here, np and square root, and pass in x squared plus y squared, like that. And that's all it's going to do. Then I'm going to go and create a bunch of x's, and I'll create from -6 to 6, and I need 30 of these. And I'm going to do the same thing for my y values, exactly the same thing. And I am also going to have to create a rectangular grid out of the two given one-dimensional arrays. So to do this, you go x4 and y4 is equal to np and mesh grid. And whenever I talk about calculus in an upcoming tutorial, I'll get more into 3D plots and such. And I'm also going to go z4 is equal to get z, to get our z values by passing in the values of x and y. And then another thing you can do is change your viewing angle on your three-dimensional space or three-dimensional axes. And to do that, this is something else you can do and go and play around with. Let's say that I want to change my viewing angle on this to be 45 degrees, and I want to rotate it by 55 degrees. It meaning the actual three-dimensional item that I'm looking for. And then to actually create it, you just go axes again and say contour 3D and pass in your values for x, your values for y, your values for z. I'm going to say 80 and my color map, and I'm going to use blues again, cause why not? And if I run it, you can see there is the contour map. And this 80 represents the number of contours. So if this is smaller, you can see there's less. And if there is more, there is more. So it sort of determines how nice and smooth this is laid out. But if you want this to be even smoother yet, well, let me show you something that's even more rough. So let's go get rid of this. And let's say we wanted to do a wireframe. Here, what I'm going to do is I'm also going to show you how to do labels. Forgot to do that. So let's do axes and 9 to just set X label. And this is just to keep this very simple, I'm going to make this X. And I'm going to do Y. And you guessed it, also Z label like this. So there you go. That's how to do labels, and you can also do titles. And here, what I'm going to do is show you how to do a wireframe, and then after that, I'm going to show you how to do a smoother surface plot. So we can just do axes, and I'm just going to use the same data again because it doesn't really matter. So I'm going to say plot and wireframe, and then we're going to pass in our same exact guys here, like this, and pass that into that. And I'm going to make the color, it's just going to be one color, and let's just stick with our current way of doing things and do blue. I spelled label wrong, sorry about that. So label and label and label, and there you can see is our wireframe. All right, now let's say that instead of a wireframe, I want to smooth this out. I can do that as well. So what am I going to do here? Basically about the same. This is going to be plot though and surface. Let's just copy that, paste that in there. And this is surface. And I'm going to need all of these guys again. So let's just copy them, paste them inside of there. Our stride is equal to 1. And this is just going to be basically a wireframe with filled surfaces. So I'm going to have the C stride be equal to 1. I'm going to define a CMap. Again, this is going to be more shaded. Whoops. CMap is equal to blues, and you'll see the gradients. And you can also do edge color, but I don't want to do edge color. So I'm going to say edge color is equal to none and run it. And there you can see that beautiful thing. All right, so there you go. There's a whole bunch of different three-dimensional plotting options available to you. And now I want to show you a really cool module that is called the Finance module with Matplotlib. Now you're probably going to have to go and install this module. You can see it right here. I installed it with pip, so I just typed in pip install mpl_finance, and you can also do that with conda if you'd like, however you would like to install it. Just type in that command in your terminal or your command prompt if you're on Windows, and it will install there. And then what you're going to want to do is update it. So you're going to type in pip install -- upgrade mpl finance like that, and then everything is going to install that you need. And now we can start having some fun with it. So it is going to do all kinds of really cool things with stock information so easily. So MPL Finance as, I'm going to call this MPF. And what I want to do here is go and get my stock data. So I have Google and PD, read, CSV, and I have this file, .csv. And index column is going to be the first one. And I'm going to say that I want to parse the dates is equal to true. And it's going to work with the Google data that we saw previously. So it's going to be really awesome. And you want to see this? There it is. So it's going to automatically work whenever you have date, open, high, low, close, adjusted. It's looking for this type of data. All right, so then I need to define what I want to use for my index name, and that is going to be the date. And then after I do that, I can come in here, and let's say I wanted to do a candlestick chart. I can't really explain why all this stuff's used for technical analysis. I'm just going to go in and just show you how to do it. So we're going to go MPF plot, and I go and get this data frame. So data frame like this, and type is equal to candle. Boom. And it automatically generates that. So cool. By date, by price, all right there. All right. You can also go and get, remember we went through all that hassle to print out prices? Well, with our time series, when we talked about that, here you can just type in a line and it does it for you, and it's really cool. And what else can we do? We could also do trend lines. So what I'm going to do with this is basically show moving averages, which are going to provide trend information, meaning do we expect the price to continue going up or not? To do that, you type in OHLC like this, and then you can define multiple different moving averages. So let's say I want to base the moving average off the previous 4 days. Did that. I don't know if you can quite see it, but there's a line right here showing you the moving averages and such. And another thing you can do is you can define multiple different moving averages, which is really cool. So let's come in here and let's say you normally want to do 3, 5, and 7. You want these to all be odd or all be even. So we're going to have one moving average based off the previous 3 days, the previous 5, and the previous 7. And then let's say I also wanted to see volume data because that's in my chart. So I can also say, do I want to see the volume data? And say, yes, I do. And do I want to show non-trading days in my volume so that I can tell when, you know, the weeks ended and so forth? So I can just say show non-trading like this is equal to and true, because that's valuable also. And there we go. I created 3 different moving averages based off of 3 different moving averages. And there's the volume information, and everywhere you see a space is a weekend or a holiday. And this is extremely valuable whenever you're making stock market predictions, and it is really fun to play around with. And you can do all kinds of other different charting if you have intraday price changes, which means price changes as the day proceeds. But I think that's a good rundown of Matplotlib's finance module. And to end up everything, what I want to do now is talk about heat maps. Now, basically, a heat map is a color-coded representation of data from a 2-dimensional list. So what I have here are 4 different pieces of data. And what it is it's going to be symptoms. So people go into the hospital and they have either symptoms of the coronavirus, influenza, pneumonia, or this is shortness of breath. This is the technical term for it, and I'll probably mispronounce it, so I'm just not going to say it. All right, and here are all of our dates, and here are our percentages for all the people that went to the hospital. So what we want to do here is analyze how the craziness of the coronavirus is affecting other people going into the emergency room for these other different diseases. So I'm going to go figure and 10 and axes and 10 is equal to plot and subplots. And then what I want to do is IAmShow is going to define the data to plot out all of this information. So I am going to say axes and 10 IAmShow, and you pass in symptoms, and also I'm going to use a color map, and I'm going to use a different color map just to show you another one. You can play around with all those, are kind of neat. Whoops, and this is going to be symptoms percentage, and you can see it went and created our color map for us, but it doesn't really tell us anything. So what we want to do is take these numbers, put them down there, and then also get some label information. So what I want to do is I want to add ticks at the data points and labels. So I'm going to say axes 10 dot set and x ticks and np arrange, and this is going to be based off of the number of dates that we have. And let's go copy this, and we'll do pretty much the same, a similar type of thing anyway. So this is going to be set y ticks, so y ticks np arrange, and this is going to be the number of symptoms. All right, and what else do we want to do? I am going to add labels to each of these. So we're going to have symptoms, this array, and then we're going to have dates across the bottom and symptoms on the left side instead of having 0, 1, and 2, and 3. And these down here, we're going to have dates down here, and we're going to have the different symptoms on the left side of the screen. So let's go and do that. Paste this inside of here. This is going to be set, and this is going to be X tick, but this is going to be labels instead. So labels, and then inside of here, we are just going to have Let's get rid of all that. We're going to throw dates across that guy. Or this is going to be X. Oh, you know what I did? Didn't mean to do that. Let's go and get rid of this. Let's go and change this to Y ticks. And then this is going to be symptoms. Sometimes I get ahead of myself. So we got that guy right there. Let's put this up here so we don't get confused again. And there that is. And then we're going to have our labels. So let's get rid of this like that. Okay, so let's do this again. So I'm going to say X tick labels, and this is going to be dates. And then we're going to have the words that show up in the symptoms area be the Y, and this is going to be symptoms. So symptoms. There we are. Now if I run it, you can see all of these guys. Now sometimes if you have a whole bunch of dates though, these are going to sort of run into each other. So I don't want that. So I'm going to fix it, and I'm going to say plot, and you can actually turn those words. So I'm going to say that I want to set them so that they are rotated 45 degrees. So to do that, I'm going to say axes 10 and get X tick labels, and I want to rotate them. Rotation 45 degrees to the right like that. And I'm going to use a rotation mode of anchor. That's what I always use, like this. And you can see now they're rotated 45 degrees. So you can fit more of them in there and still be able to read them. And the final thing is I want to go in and actually put all of the different numbers inside of here. And then we can analyze our data. So what I need to do is loop over the data dimensions and create different text annotations for them. So I'm going to say for I in range, and we're going to get the length of the symptoms. So symptoms, and then we're going to do pretty much the same thing like this, and just change this to J, and this is going to be in range, and this is going to be the dates, and then we just set the text for them. So we say axes and 10 and text and J and I, and we go and get the symptom percentage that is inside of this. So we want all of these numbers out of here. So it's symptoms percentage, and then this is going to represent our cells that we're printing into. So I'm going to say I and J, and what else do we want to do here? I'm going to say that I want them to be centered inside of those cells, and vertical center, and I'm going to say that I want them to have the text color of black, and I'm also going to say that I want my font weight to be equal to bold. And if I did it, you can see there is our heat map with all of our values, and you can see over time the number of people going to the hospital with symptoms of coronavirus, and it started to go down. Now it looks like it's going back up. You can see that the number of people going to the hospital with symptoms of influenza is falling. You can see the people going to hospital for pneumonia is also falling, and shortness of breath are also falling. So basically this is just telling us that people aren't going to the emergency room anymore, at least in the United States. Okay, so there you go. Rundown of a whole ton of examples of some really cool things we can do with Matplotlib. And next I'm going to cover Seaborn, which is going to further extend and really make just amazing visualizations and charts and plots and all kinds of other cool stuff. If you guys actually stayed here to the end, please take a second and tell me in the comments, because I am very happy when anybody actually watches the whole video, because it rarely happens. And like always, please leave your questions and comments down below. Otherwise, till next time.